This video is about safety. Before you use any active network assessment tool in an OT environment, you need to understand that these tools behave differently in industrial environments than in IT environments. The risk is real. It's documented and has caused process shutdowns and operational disruptions in actual facilities. It's the reason experienced OT security practitioners treat assessment tooling differently than their IT counterparts. Active scanning tools are tools that discover network devices by sending packets to them and waiting for responses. These are used routinely in IT security assessments. Running Nmap across a corporate network to discover what's there is standard practice. IT operating systems, servers, and network equipment are designed to handle a wide variety of unsolicited incoming traffic without failing. OT devices, however, were not designed to handle unexpected network traffic. The TCP/IP stacks in PLCs and RTUs are very minimal, implemented in firmware with limited buffer space, designed to handle only the specific protocol traffic they were built for. A port scan works by sending packets to every port from 1 to 65,535 in rapid succession, looking for responses. That's tens of thousands of unsolicited packets arriving at a device in a few seconds. Legacy PLCs and RTUs receiving that kind of traffic have been observed to fault and stop executing their control programs. The control application halts. The outputs go to their configured fail-safe states or hold their last values. In a best case, an operator notices the PLC has faulted and manually resets it. In a worst case, the process continues without automatic control until someone responds. Again, this has been documented in CISA advisories and in post-incident reports from real industrial facilities. The message is not never scan OT networks. The message is never scan OT networks without understanding what you're scanning, with a maintenance window and a recovery plan in place. The failure modes from aggressive active scanning in OT environments span a range of severity. Again, a PLC faults and its program halts. The immediate effect depends on that PLC's fail-safe configuration. If outputs are configured to hold the last state, the process continues at its last set point, which may be fine for a few minutes or may be dangerous depending on the process. If outputs are configured to go to a safe state, typically de-energized or closed, the process shuts down. A legacy HMI application crashes and requires a manual restart. During the restart window, operators have no display. If they're watching the process through the HMI exclusively, they're flying blind. A managed switch becomes unresponsive and requires a power cycle. All devices behind that switch lose network connectivity simultaneously, potentially including PLCs that depend on network connectivity for their controlled communications. A safety-critical process triggers a protective shutdown because the control system becomes unavailable during the scan. A shutdown in itself may be safe. The restart procedure for certain industrial processes is complex, time-consuming, and in some cases costly beyond the immediate downtime. So none of these outcomes are acceptable in a production environment, and none of them require a sophisticated attack. They can be triggered by a well-intentioned engineer running a standard IT security tool without understanding the OT context. If you determine that active scanning is necessary in your environment for a scheduled security assessment, a new equipment audit, or a specific diagnostic need, these requirements apply before you begin. Written authorization from the appropriate operations authority. In most OT facilities, this means the site operations manager or plant engineer, not IT security, not the OT security team alone. The person responsible for the process must sign off on the risk and the maintenance window. A maintenance window where the affected process is in a safe state and personnel are prepared. The relevant field equipment should be in a safe operating condition, not in the middle of a batch, not at a critical transition point, not with operators relying on the network for real-time control feedback. Personnel should be stationed to respond immediately if devices fault. A recovery plan before you start. Know the procedure for recovering a faulted PLC, an unresponsive switch, and a crashed HMI. Have the relevant passwords, recovery procedures, and vendor phone numbers ready before any tool runs. Lab testing first, with the same device models and firmware versions as the production environment, if at all possible. Behavior that's safe on a new firmware version may not be safe on the firmware ready in production. Don't assume. The good news is that many of the most valuable visibility goals can be achieved without active scanning. One idea is you can query the router's ARP table, a passive read operation that doesn't send any packets to field devices, and it will reveal which devices have been recently active on each network segment. Switch MAC address tables show which MAC addresses are present on each port. These passive methods build asset inventory without sending any unsolicited traffic. Dedicated OT network monitoring platforms like Claroty, Dragos platform, and Nozomi Networks Guardian are designed specifically to provide network visibility in OT environments without active scanning. They work by passively observing the traffic that's already on the network. They see every communication, every device, every protocol, and every connection without generating a single packet of their own. We'll cover these tools in more detail in the next video. The principle is, prefer passive methods in production OT environments. Use active methods only when the passive methods aren't sufficient, with proper authorization and a maintenance window. In the next video, we'll start with the safest active tool available, ping. We'll see you in the next video.